Okay, so I'll go over this again. So this is part 2 for 3.3. How can we prove lines are parallel using our Converse theorems? So we have that A, B, C, D, E, F, G, H. So draw your line. This is our transversal and our parallel lines, which we have to prove that R is parallel to S. Okay, so we need to prove that they're parallel. We're given that the alternate interior angles are congruent. So I'm going to pick angles C and F. Okay, so we're going to do our 2-column proof. So if angle C is congruent to angle F, because that's our given, then angle C is also congruent to angle B by our vertical angle congruence theorem. So if angle C is congruent to angle F and angle C is congruent to angle B, then angle B is congruent to angle F. Do you see that? So angle B and F by our transitive property. Transitive property, okay? So that means that line R is parallel to line S by our corresponding angle converse. And you're going to see that as CAC. Okay, so just remember that we have that proof. Okay, so what if we have this one? So what if we wanted to use that to prove that some angles are congruent? So let's say everybody, so we have this. Okay, so we have line M and line N. Okay, and we needed to prove. So we have this one is 2x plus 12. And this one is x plus 34. Okay. So which converse would we use, everybody? So this one, they are on opposite sides outside. So they're on opposite sides of the transversal and they're outside. So we're going to use the alternate exterior converse. Okay. Their angle relationship is that they're congruent. Okay. So we're going to set those two equal to each other, everybody, and go ahead and solve. So 2x plus 12 is equal to x plus 34. Remember, it has that invisible 1 in front of it. Subtract x from each side. So we get x plus 12. This would be 0. We bring down the 34. Subtract. Use our subtraction property of quality. Subtract 12x from each side. 34 plus minus 12 is going to be 22. If they asked us to find the angles, we would just substitute in 22 plus 34. So that would give us 56 degrees. So if they asked us to find the angles, everybody. Okay, what if we had this one? So 3x plus 21 is equal to x plus 57. Okay, so we'll look at the angle relationship for that one. So we're going to use, those are same side, skip one. Okay, so we're going to use our corresponding angle converse, which means that they are congruent. Okay, so we're going to set those two equal to each other. So 3x plus 21 is equal to 57. Okay, I subtract x from each side. So I get 2x plus 21 That would be 0 is equal to 57. Okay. Subtract 21 from each side. We get 2x is equal to 36. Divide each side by 2. Using our division property, and we get x is equal to 18. Okay. So for this one, so what if we had another example? Just keep working with these. So we had 2x plus 42, and x minus 24. Okay, so what if we had this one, everybody? Well, which Converse would we use? So they are on the same side of the transversal. So same side. Okay, so same side inside. So that means we're going to use our consecutive interior Converse. Okay, so that's what I'm going to use. Okay, they are supplementary. That's how they're related. So we're going to set that equal to. So we're going to go 2x plus 42 plus x minus 24 is equal to 180. We're going to combine like terms. We're going to add our x's. And 42 minus 24. So we're going to get 3x. Plus 18 is equal to 180. Subtract 18 from each side to get 162. Divide 162 by 3 to get 54. Okay. Part 2 continued. Today is still at 29. Section 3.3. Okay, so we're still working with our Converse theorems. So let's say, everybody, what if we had like this one? And we had x plus 23 and x plus 61. Okay, and our lines M and N are parallel. Okay, so we need to prove that they're parallel. So we're going to use, if we look at them, everybody, they're on the same side outside. So they are consecutive exterior. So we're going to use our consecutive exterior Converse. How are those angles related? They are supplementary. Okay, so we're going to go x plus 23, x plus 61. We're going to set that equal to 180. We're going to combine like terms. We're going to add the x's together. X plus x is 2x. We're going to add the numbers together. So 23 plus 61 is 84. 180 minus 84 is 96. Half of 96 is 48. Okay. Okay, what if we had this one? Okay, so we have 2x plus 52 and 3x minus 55. Of our lines M and N, we need to prove that those lines are parallel. So we look at the angle relationship. They are on opposite sides inside, so they're in between those two parallel lines. So they are alternate interior angles. So we're going to use our alternate interior angle converse. And they are congruent. So we're going to set those two equal to each other. So we need to solve for x. So what value of x? We prove that those lines are congruent. So we set those two equal to each other, subtract 2x from each side. So 2x from each side. So we get 52 is equal to x minus 55. Add 55 to each side. We get x is equal to 87. Okay, what if we needed to prove? Okay, okay, so everybody, when I look at those, I go, what's the angle relationship? Well, those two actually don't have an angle relationship. So what we're going to take is we're going to take but we know vertical angles are congruent. So I'm going to move, remember vertical angles are congruent. So I'm going to move this x plus 54 here. So when I do that, now I can use one of our Converse theorems. So that would be that those are consecutive exterior angles. They're on the same side outside. Okay, so consecutive interior angle converse. And those two are related because they're supplementary. So we're going to set those two equal to 180. So x plus 24 and x plus 54 is equal to 180 degrees. Combine like terms, so we get 2x plus 78 180 minus 78, 102. Half of 102 is 51. And we got it, everybody. Okay. What if we needed to prove okay, what if we had this? So we had x plus 7 and 3x minus 17. Okay, so how could we do this? Okay, again, everybody, so I can take and move, right? Because I know my corresponding angles are congruent. So if this is x plus 7, this is also x plus 7. So now I can use my corresponding, well, they're on the same side of the transversal. So they're on the same side outside. So again, we can use our consecutive angle. It's like consecutive exterior angle, converse. And we know that they're supplementary, so we just did that one. So we'll go x plus 7 plus 3x minus 70 is equal to 180. So we're going to get 4x minus 10 is equal to 180. Add 10 to each side. 190 divided by 4 is 47.5. So everybody can use decimals. Okay. One more example like this, everybody. So this is 2x plus 20. Okay, so again, everybody, I know corresponding angles are congruent. So I'm going to move this one up. So if this is 3x, this angle is 3x. This angle is also 3x. Okay, so we're going to use our, they are on opposite sides, outside of the transversal. That's like, oh, I should put arrows on these. Alternate exterior angle converse. And they are congruent. So we got 2x plus 20 is equal to 3x. Subtract 2x from each side. And we get x is equal to 20. And that's it, everybody. Okay, everybody, you got this.